So the demonstration I'm going to do for you now is pretty simple to do, pretty complicated to really understand, but you've got everything that you need to understand this. And it might be something you've seen before. Most kids haven't, but there are things like this, and there are applications to the real world. And what I've done is I've cut up a bunch of pink paper. I use scissors and cut, I don't know, a few hundred little tiny pieces of paper. And I've got this nice blue balloon. I'm gonna blow it up for you, and we're going to use it in this demonstration. And again, balloon is an electron WIMP. Okay, balloons steal, it's an electron bully, sorry. Okay, so we have a balloon which pulls on electrons hard, not only its own, but other things' electrons, and it can steal them away from things like, this is a cotton shirt, and cotton is an electron WIMP. So when I rub the balloon on the shirt, it will give it a chance to steal electrons and get a negative charge. Then I will hold the balloon over the tiny little bits of paper, and I'm going to try to explain right now what's going to happen. And I did a drawing, which, as you all know, is painful for me and usually doesn't do any good. But I'm going to hold this up and hope that you can see it and make sense of it. So this is the neutral balloon. So I'm gonna like all good experiments, there should be something to compare it to, and I'm gonna do it. First, I'm gonna lower the balloon without rubbing it. So the balloon's neutral, the paper's neutral, and that's what I'm trying to show in this drawing over here on the left. Okay, negative, positive, electron, nucleus, electrons, nucleus, electrons, nucleus. Everything is evenly spread out, and the same in the balloon. It's a neutral balloon, a neutral piece of paper. Then I'm going to charge the balloon. For the second one, I'm going to move it close and close. You can see here it's further away, there it's lower, but negative in both. So this is part one of the experiment, and then these are going to be two stages of part two. And you can see that the balloon is negative, and what happens, these negative electrons are moving, and it's almost like they're moving to hide behind the nucleus, right? They're moving around to the back of the atom. And what we're going to end up with is the edge of the paper toward the balloon will have a concentration of positives, because the electrons, the negative charge, has moved away from the negatively charged balloon. So that is the electromagnetic force of repulsion going on here, where the negative balloon repelled the negative electrons and they moved away. Okay, and then what we're going to see is the positive edges of the paper are going to be attracted to the balloon. And so the reason I call this paper popcorn is what I'm hoping is that we can actually get the paper, the little pieces of paper, to move, right, to accelerate toward the balloon and stick to it. Believe it when you see it. Okay, so I'm going to try to get the camera focused in on the pink paper. So that'll take me just a second, but I'm not going to... Okay, so here we go. Okay, and then I'm going to... Okay, I'm learning how to use the telephoto feature a little bit here. Pretty impressive, right? Okay, so you can't really see the balloon being lowered, so I'm going to have to tell you what I'm doing. Here's the balloon. I have not rubbed it. The balloon is neutral. The paper is neutral. I'm moving the balloon down over the paper, and nothing really happens, okay? Because there are no forces. There's no electromagnetic force going on here between the paper and the balloon, so it's just the force of gravity holding the paper down. So now I'm going to rub the balloon vigorously. This is part two of this experiment. So I'm rubbing the balloon bully on my wimpy cotton shirt. The balloon, I'm hoping, is stealing electrons. I'm giving it as much chance as I can. rubbing it vigorously. Okay, and now I'm going to slowly lower the balloon over the paper, and I'm hoping that we'll see some. Okay, can you see that? Standing up. Okay, definitely. Can you see that? Like paper, the paper is the positive edge of the paper. You can. Okay, you can see that it is this electromagnetic attraction is stronger than gravity. Hoping that you can see it. Well, hopefully I'll have time to watch it before I put it put it online and make you watch it. Okay, so there we go. The electromagnetic force of attraction caused by an induced charge, which was due to the electromagnetic force of repulsion. So this is a good example of both. Okay, that's long enough. Thank you.